In this video, I'm going to explain about DBScan algorithm. First of all, DBScan algorithm is an unsupervised learning for clustering. And the full form of DBScan algorithm is density-based spatial clustering of applications with noise. Well, there are three particular words that we need to focus on from the name. They are density, clustering, and noise. It is clear that this algorithm uses density to cluster the data points, and it also has something to do with the noise. Right. Now let us understand what actually the density is. Let's say we have a region with some data points, and we also have the same region with other set of data points. Now, when you observe this here, the density of first region is greater than second region because there are more data points and more matter in the first region. Now, DBScan uses this concept of density to cluster the data. Now, to understand DBScan algorithm clearly, we need to know some important parameters, what actually they are. The first thing comes is epsilon, and the second one is min samples. Min samples or min points, minimum points, whatever. Now let us understand here what actually the epsilon is. Epsilon is a measure of neighborhood. Suppose we have a point here, consider letter A right now. Now when I draw a circle around this point, and this is making as a center here A, and adding a distance d with epsilon. Here, epsilon is just a number that represents the radius of the circle. So this is about epsilon. Now let's go to the other point, which is called min sample. I'm going to represent min sample as Z here. Now here we are trying to give some threshold value here. Let's say we are trying to put the least number of points for Z is 3. Now, if we have 4 points in our neighborhood, this will also satisfy our threshold, which is our Z equal to 3, because this threshold represents the minimum number of samples in a neighborhood. Now, based on these two definitions, we are going to classify three categories. They are core points, border or boundary points, and noise points. Now let us talk about a core point. Now here I have represented here the core point as A, right? When we are saying it is a core point, it should satisfy one condition. What is that condition? The condition is the number of neighbor must be greater than or equal to our min samples here. So you can see here we have our samples 3, so which is actually satisfying the conditions, hence we can say this is our core point, right? Now let's see the second type of point here, which is called as a boundary point or a border point. Now now in order to say the point is a boundary point or a border point, it has to satisfy two conditions. The number one is the neighbor the number of neighbors must be less than z, right? Here it should be less than z, and the point should be in the neighborhood of the core point. So this point is the neighborhood of the core point, and also we have our data points which are less than z here. So it satisfies this condition, so we call this as a border point. Now here this is about our border point. Now let's go and talk about noise points. So the definition of noise point is a very simple. It is a point, neither a core point nor a boundary point. It is just a point just left to itself, and it is called as noise point. Here in this figure we can see it here with the point C is neither a core point nor a boundary point. So we can say this as a noise point. Typically this is an outlier in our dataset. Alright, this is about DB scan algorithm. I'll talk about some more videos in our next video. Thank you for watching.